Another day, another tube. This A-pillar bar isn't quite as super ultra tight fit as I was hoping for, and a big part of that comes into the curvature of this A-pillar. Like, it's just very difficult to get to lay in there, match up, meet the tube up on top, and there's a bend here and another bend right after it, kind of a thing, in order to make it work. And I don't think it's worth the time and effort to try to chase that super extreme fit, simply because the tube is absolutely in its general area. If I go put myself in the seating position or close to where it is, I can actually see the top of this A-pillar, so this bar will be losing me basically zero visibility loss, which is awesome. Like, that's kind of the whole point of doing this versus this tube being over here with all the stock sheet metal taking up that spacing and losing, a couple inches of visibility on this side. The passenger side, not as big a deal, but it's definitely going to matter on the driver's side, especially with the way set back driver's position. We're hitting really nice on the halo bar, and it's fitting pretty close to where I cut the sheet metal up in the front here to make it fit. It's, again, not a ultra perfect fit, but I really got to work with kind of what it was, because I was guessing where I was making the cuts and all that. I'll be able to build some new sheet metal A-pillar parts here. They'll actually kind of just come out and wrap around this bar, or just tie into it and it'll be welded, or we'll have basically a gusset plate kind of a thing to finish this off, top and bottom. Working through the bends was pretty difficult, just because I couldn't ever actually stick it into position until we were down to final fitment. I started out with a 40-degree bend that I kind of eyeballed for the first one coming off of the upright tube section, and then kind of decided to keep going and ended up at 45 to get closer in line with the A-pillar bend itself, so that I just had less compound bend to do at the second one. And once I had that kind of eyeballed, everything was moved in a little bit and set up with the tube laying on top of the roof here, and just kind of eyeballing what that angle needed to be. And really, I ended up just kind of taking my clamp block and eyeballed what that compound curve needed to be, because the tube was still high and angled out, so we needed to pull it in and up at the same time. And I'm not even sure how you could properly measure that, so it's just like an eyeball it kind of thing. And then I just made sure that I could get down as close to the first bend as possible to minimize this distance here. That was going to be a straight section. And after I knew it was working out pretty close, I needed to figure out what the cope was going to be up on the top. So I just took this shorter piece that was left over from the main and the halo and laid it in here and slid it up, and then cut it so that it fit. And once I had that cut, I was able to take a piece of paper and lay on top to get a general idea of what it was, and marked it in line of the edge of this A-pillar, so that when I laid the tube next to it and marked that, I could then line the cope up and get it roughed in the same spot. The nice part is when I go to the other side, I should be able to just reverse this piece of paper and wrap it around the tube the other way, and still be able to use that in reference for the other side. From this angle, you kind of see how complicated these A-pillar bars are. And it should be pretty obvious about why it's so much easier that I went with the halo route versus doing these all the way back to the main hoop. And it's just because of the multiple bends in multiple different directions kind of a thing. My first bend for the driver's side started out exactly the same as what I did on the passenger side. Basically, I was just copying what I was doing. When I went to put the second block on, we needed to go in the opposite direction. And that was just a matter of, you know, making sure to put it on facing the right way kind of a thing. I set this block based off of that witness mark, just like we did on the main hoop of where the die was riding at. That gave me a repeatable location side to side. And it didn't have to exactly line up with that. I could have measured, you know, to either side a set amount, but it was just about the right distance for where we're making the second bend needed to be. And then also when I put it in the machine on the first side, as I said before, I was eyeballing that. But before I pulled it out of the machine, I measured with the gauge cube parallel with the bend. So actually the way it was sitting, it would have been on this block and it would have been sitting at a goofy, you know, at an angle to line it up with this bend. And got a measurement that way. And I also turned it and set it on the tube itself in order to get a second measurement, and I did not bend this one until I had those things matching on this side. And I've already put it over there, kind of check fit it, looks pretty good. I'm ready to pull the clamp blocks off and make my cope. But the big thing was this, I could get one to match and the other one didn't quite match, and I didn't just go with one of them. I made sure to get both lined up, because actually the way it sat in the machine, depending on where it just happened to be tilted without any pressure on it, changed what the tube reading was, but not as much what the block was doing. So I made sure that I moved both around until I had both numbers matching and made the bend, and it looks like it's going to be very, very good. Here you can see me checking back and forth with the angle gauge to check that both sides of the A-pillar bars are matching each other. And we're off by about 1 degree on the lower bar and 1.5 degrees to 2 degrees on the upper section of them. And really that's not that big of a deal. Like if we start measuring to compare to the body, especially along where the windshield rides, it's within 1/8 of an inch across that entire section. So we're actually very, very close. I'm not too worried about just a very slight degree angle difference. You'll never be able to see it across the car without putting the gauge on it, and we're matched up in the same places up on top and down on the frame, so everything's good there. As well as, you know, if we want to call in the middle being along the windshield rail there, that looks pretty consistent side to side as well. I want to take a minute to go over a few different options as far as welding the top of the cage and dealing with the roof being in the way, just because it's been brought up both on the last video and on my build thread on Grassroots Motorsports. And my plan is to basically cut out a small square area just above the tube so that I can weld it in, make sure that I'm nice and tight to these two different angles so that'll keep the shape, and then there's plenty of room in here to get hammer and dolly and level it back out. Other options are being able to actually make it so the body will lift up, because right now the only thing that's actually holding me back on that is this rail overhang that's underneath the halo right now. And I haven't cut that out because it's a big part of like where the window seal goes. Not that this is gonna have windows, but I've got kind of in the back of my head that if I ever got the desire to convert this back to a street car, obviously those are things I'm gonna want to be able to have going on. But at the same time, I've already been thinking I want to modify the B-pillar back here and kind of wrap around the cage so that this becomes a more aerodynamic device, kind of like the 1980s NASCAR stuff. So, like, that part of the window seal thing is going to be completely gone anyway. So I probably shouldn't be all that attached to this bit of sheet metal up here. Another option that could be is I could leave about a 1/2 inch wide ledge all the way around and cut the entire roof section out, at which point it'd be pretty cool to like do a carbon roof. However, that's a lot of time, effort, and learning a new skill about composites to be able to do some carbon fiber that I really don't have time for. Well, not that I'm on a schedule here, but it's going to be a big time investment, and to do a carbon roof roughly this size there, I would not be surprised if I end up with $800-900 into materials just to make it happen, kind of a thing. You know, if I knew somebody personally that was local that like has done this before and could help me do it, I'd probably be way more on board with that option, especially because with that out, we'd have more than enough access to do anything, plus be saving just a little bit of weight going to carbon. And we could even integrate some reinforcement strips into the roof shape where I don't have to do it in sheet metal afterwards, which would again save some more weight. Another option, which got brought up on the forum, is just cutting the roof off, which I didn't think about this at all, and then one of the guys on the forum posted pictures of him doing this to like an S10, and that is intriguing because you'd only have this like 1.5 inches of material that actually was visible to weld up here in the front. And the natural, there's actually a body seam right about this height that I'm guessing is leaded. It's really hard to tell, you know, with the body being finished out, but it might be just a leaded seam along here, which makes for a fairly easy thing to patch. The only hard part there is that my main hoop tube is really tight to this area right here, where there's no way I could get in there and body work it afterwards, you know, trying to set everything back down if the body itself is staying and only the roof is coming off. So, like, you know, but if we lifted the body up afterwards, like, then there's options there. But again, you know, if we're leaving the sheet metal underneath the halo, we really can't lift it off afterwards anyway. So if we got to cut this just to be able to facilitate that, why would we cut anything related to the roof? But again, that would be another option where same thing, it all comes up out of the way. It's, you know, easy to then weld the top of the cage. You can set it back down and it's minimal body work to fit it back in. And in these sections, it's probably a lot easier to blend it out and make it look right than maybe my little small patches on the roof section itself, simply because this is such a big sheet curved in multiple directions that any welding up here is going to really kind of pull and push on it, and it might cause bigger wrinkles across the whole thing. So that's where, you know, chopping at the roof would be definitely a possible option to just lift the whole thing off, and at that point I could probably make a slit and peel some of this material out of the way. And now that I'm saying that, that might be my best option right now, is if I just cut a slit on both sides and I can bend the sheet metal down for now, it would allow the body to lift up past the cage. At this point, I'd say the most difficult bars are all done, because now we're going to be working largely with straight tube sections. Up next, I'm going to do the down bars in the back. So I've already measured that out. We start with a 42 inch. You're just going to put a cope on one end, put it up against the main hoop, and we'll just have to figure out what angle it is to land on the frame in the back. Shouldn't be that big of a deal. We'll have a diagonal bar in the main hoop here. Put that in first. We'll do harness bars last, because we should really base those off of seating position and making sure we've got the correct angle on the belts to make sure that it's properly safe. And besides, the diagonal over the driver is definitely the more important bar than the harness bar is. Even though the harness bar would be nice, easy, straight, 2 copes on each end, the diagonal one's more important, so that should be the solid bar. Although it's not a requirement based upon rule sets. We'll also have the dash bar in the front. That'll just be a straight across. I'm not quite sure on height yet. I think I'd rather wait a little bit on that until I can test fit the doors a little bit and decide what I'm doing with the door bars, because I want to like note everything in. So we should have a door bar coming in, the dash bar coming in, we've got the A-pillar bar coming down, and we'll have the front bars that are going to go up to the front suspension coilover mounts and then all the way up to the front of the frame. So those might be a little more complicated bar when we get there, but again, shouldn't be that big a deal. It's just, we're at a point, let's knock out some easy bars and get this at least make it look like a lot more progress happens in a short amount of time. Alright, so as you can see, we don't have the greatest to fit up there right now, but I had to keep cutting material in order to find out how and where it was going to fit. And this is a little bit higher than I want it to be anyway. I would like to move more of the tube down onto the frame itself versus up on this coilover mount. And I mean, ideally, I think right about where this corner is, if that gets down to the top of the coilover mount, we'll be in a good spot. So I'm going to keep cutting a little bit more material off the top here. I got to cut some off the bottom, and that'll be a non-issue because we've just got a straight cope up there in the corner. That won't be an issue because we've got a straight cope up here in the corner, and it will be able to rotate either way without changing much. Now that fit up is a lot better. Still a little bit big on that notch there. However, I'm not really worried about it because the rest of it looks really good. Now I will say there are a couple of different ways to, I don't know, think about what the fit needs to be. I mean, there's definitely make a perfect fit every time kind of a thing. And what I've kind of run into doing some cages and a lot more with like control arms where I'm really worried about, you know, it's a suspension part. So if it fails in a weld, that's gonna be, you know, what causes the car to crash kind of a thing. And I found that like if you have the perfect fit up, it's pretty tough to get proper penetration, especially with MIG welding. With TIG welding, you can sit there and you can really heat it up and burn that puddle in to make sure you're getting full penetration. But if you're MIG welding, it's going to start piling up the material on top before it ever actually gets down to the root. unless you cut back to a less good fit. That way you know your weld puddle is getting all the way through to the bottom side of both pieces. And versus if you have a good fit and you're putting that weld on top, you need to be hot enough to burn through it. And typically with doing roll cage or control arm type things, you're doing such a short little bit at a time that even if you have it set where after you move a small distance, it's getting full penetration, where you started that weld is going to be cold and it won't have full penetration. So I'm much happier having a fit up like this, where maybe I got a little bit too big of a gap in a few places, where I can then make sure that, hey, I'm gonna sit there and I'll just put some fill weld in, and I know then for sure that I've got full penetration on both pieces. You know, even just because I have to fill it in a little bit, versus if it's like super tight. For example, right down here in this crevice is going to be very difficult to get to, and there's almost no way that I'm ever going to be able to make full penetration with a MIG welder all the way into the root of that. So what's going to happen is, as I'm coming around, probably somewhere right around the tip of my finger here, we're going to transition from trying to get full penetration all the way through to we're going to have to like start lapping it up and building a weld bridge between here, where, you know, the tube to the frame itself is not going to be the full penetration, but will be fully welded between the frame and the tube a little farther up the tube. The only other way around this is going to be if I actually ground the tube back far enough that I had air gap in there that I knew I could then go fill. So really it's coming down to kind of personal preference on that. I mean, the better you make it fit, the prettier the weld will be on the back end, especially if you're TIG welding. But if you're just kind of DIYing this in your garage, and it's less important how it looks, and it's always important about whether it has a proper weld, having a perfect fit up is not a make or break. Another visual reference for that is going to be, you know, this cope cut here that's just straight cut with the hole saw. You know, this 1/8 inch thick of material, if you have no gap in there, you're trying to start the weld and burn through an 1/8 inch of material to make sure you have full penetration before you start moving with your weld. And if you're MIG welding, you're just going to end up building up on top. It'll be a cold start, and if you got it cranked up, it'll probably start melting in good by the time you get around here. But if you have a really bad spot that's hard to get at, and you got to like start and stop a bunch of times, it just makes a bunch of weak points where you're not fully penetrated. Versus, you know, if I was putting this directly to a tube where it sit flat perfect all the way around, I'd end up V'ing this tube out. So I'd be pulling back this edge here by at least an 1/8 inch to kind of put it at a 45, so that when I'm fill welding it, I'm already down all the way to the root, and now my filler is getting put in on top. So just because you got a perfect fit up does not mean that it's ready to weld. Now I've got the other side fit, and this one I ended up with a lot better fit to it. However, what we've been talking about here is a perfect example. See that area right there? Fits really tight. This side too, and a little bit over the top. Those three areas are for sure going to need to be ground back to at least what this less good fitting area looks like before it will be able to be welded, and know that I'm going to get full penetration in there. Otherwise, with it this tight, any weld I run across there, unless it's actually like full penetration hot when I get there, it's just going to pile on top. So I can't even start and stop anywhere in here the way it is, or you're not going to have a good weld. Well, that didn't take long at all to put those 3 bars in. So now we've got our down bars in the rear. Obviously, even though we're tucking the rest of the cage, those are going to be able to be seen. There's actually going to be a ton of stuff behind the main hoop that's going to get seen anyway, just from suspension stuff, and there's just going to be a lot going on there. other than what gets covered up with sheet metal, just because. Our dash bar isn't set height-wise, but I have it leveled out. Everything is still just kind of vice gripped in place. Nothing is tacked or tack welded yet. And I'm pretty happy with how it's sitting. The dash bar might go up or down. It's still, you know, open as far as what I can do with that. It might need to adjust it based on where the engine and transmission end up being, or maybe a little bit based on mounting my pedals. There's still a lot of variables there, so I want to be able to have the flexibility to go up or down several inches, kind of a thing. Jumping into our main hoop diagonal, we have our first super complicated cope. This side, on the passenger side floor, is not going to be complicated at all. We can just do a single cope cut to match up with the vertical. We just need to know what angle this is going to end up being. In the other corner though, we have 3 tubes, but essentially it's 4 tubes coming together because we've got you know, a little bit different angle on the bend of each side of where that tube is going to land with the main hoop, plus our down bar in the back and our halo bar in the front, and we've got to land right in the middle of all of those, or at least that's what we need to try to do. There's a couple of ways we can figure out the angle, because I would like to make the easy cope cut first, just to kind of fix that end, so as we keep test fitting on the opposite side, we can kind of go back and forth and try to get it to keep landing in the same place. The easiest way, or quickest rather, that I can just kind of do this is just going to be pull this bar, have it kind of positioned where I want it on the bottom side, and then kind of slide it on that rear main bar, or rear down bar, until the, you know, it kind of lines up with where it's supposed to land, and just go off of the angle gauge. You know, we've got 30, let's see here, make sure I got it in position, it's not sliding on me. Got 36.7 degrees. So somewhere between 36 and 37 degrees is probably where it's going to be. So I can just make the cope cut that way. Another way to do it would be, since this is a simple triangle, we could measure the distance across. That's not going to be our full length on the bottom of the main hoop, because this is in from the edge a little bit. But if we got out our laser square, we could for sure find where lining that up is, what that length is on the bottom. We can know what the height is, and we could also know what the middle length is. So we could use a trigonometry calculation in order to figure out the angle. I know it's kind of hard to visualize this, but picture that triangle kind of folded over like that. So we've got roughly 65 for our diagonal, 52 for our flat, and we have a 90-degree corner to make the calculations easy. And as you can see, we come up with a 36.87 degrees, which is obviously super close to what we were measuring just eyeballing it. So, well, we were within 0.2 of a degree. So those are the 2 ways that you can check and find that angle easily. Here's a perfect example of needing to kind of pay attention to what you're doing. I just screwed this up. So I set my angle to 36 to 37 degrees. However, this cut, way too steep for what we're doing. We needed to be the other way. So really what we needed to do was 90 degrees minus 37. So it should have been set at 53 on my cutter in order to get the correct angle, which it's alright. This is why we got extra tube. And you know what? I'm surprised I made it this far with having the first tube to screw up. But this isn't going to be wasted tube. It's still plenty long to use for something else. I'll just have to cut another piece, and you know, that's just where we're at. But at the same time, is maybe if I fix the angle, this tube is still a little bit long enough, because I usually leave them a little bit long. But I don't know, that angle might be more than the 1/2 to 3/4 inch that I added, but I'll see if it'll work out still. All right, I've recut the angle. It looks like the tube might be just a hair too short, but it might be just long enough still. So I'm gonna take the time to try to fit it. I've removed the rear down bar here. We're pushing this bar up. As you can see, it's still long enough that it doesn't go up to meet our halo yet. So I've put a mark on the top. We'll do a very small cope cut just to get it started there, and maybe just kind of keep cutting away until this pulls up to line up with the halo, and then we can worry about fitting the down tube in the back. But we'll know whether or not it's still long enough by the time we get it matched up with the halo. Now I gotta make sure that I'm resetting my cut correctly again. And it's gonna be in a different direction this time because we need to have our main hoop coming up like this and curving over the top. So it's gotta be angled in the other direction. And this time it's gonna be a much steeper angle, so that we should be able to put it right to what would be 37 this time. However, the way that this angle gauge is marked up is 0 is straight in line. So that's why when we needed a 37 degree angle, because of the direction we were cutting it at, we needed to go to 53. But now we're gonna go to 90, and if we're gonna cut 53 back the other way, because that'll be the flatter cut, but that's also only if they're going 100% to the flat of the top of the cage, and we're not. So really we don't have to get that angle just exact. And even with the way this is set up there, where at 90 you go up to like 125 here before we're kind of bottoming out. We can go a little bit past it, but not much. So really that's only giving us like a 35 degree angle anyway, if we're gonna cut it this way. Otherwise, we could pull it around and easily go to that 37 from this direction. So it's just kind of which way you want to cut it. I've got my mark on this side, so I'm going to cut it this way, and because we're a little shy on the angle, I'm not going to worry about it. We're just taking little cuts, and I want to get it close enough that we can just fit it with the flap wheel instead of using the cope cut, because by the time we start fitting that rear down bar, we're going to just have to be looking at where we got to remove metal anyway, and without having, you know, a known like actual index of degree and an angle, it gets complicated in a hurry. And it's a lot easier to just look at it and cut it as you go. So we're going to set this back to the point where we're going to have a little bit of a cut. Like right there is probably maybe a 1/4 inch that's going to come off of it. We'll look at where my line is drawn. Well, it's a little dark. It looks pretty close to horizontal there, lined up with the cutter. So we can lock everything down and make our cut. Alright, that first cut was a little bit shallow. It got us halfway there though, so I took some more. Now we got a little bit of gap there. We're still not high enough up. We're getting very close to touching on the back side, as well as we're already touching the halo bar here, so we got to round this edge a little bit. I think this is more than close enough to start trying to fit it with a flap wheel, just to get that tucked up the rest of the way. And it does look like this tube will be long enough. Woo! Now we got that fitted up pretty good. I mean, it's fitting very nice on both ends of this tube. We got our planes here very, very close. Actually, I could probably cut just a little bit more off of this tube, but I want to kind of wait and see where the down bar in the back ends up, because as we cut away material, this might slide up a little bit farther anyway. But now the hard part is doing that, getting clearance for that down tube in the back. So we're going to put our tube back in place. You can see we're definitely got some clearance issues. So now we got to be able to try to figure that out. You can start with trying to get it kind of set in position here, and maybe just run the marker around it. Gets us a shape. You can see that right there. So we can start clearancing that a little bit and see where it gets us. Should point out that there is no requirement about which tube you're cutting. The only thing that matters is that the main hoop stays a solid bar. You can't be cutting into the main hoop. But as far as whether you're, making clearance off of the halo or the down bar in the back or on the diagonal bar, I haven't seen a rule that dictates which one has to be the one that's clearanced. I'm going with the diagonal on this cage just because we've already fit the down bars in the back, and I know where those are at. They're kind of a known position, and right now I've got kind of an order of operations as far as when all of these tubes kind of get taken back out to make sure that we got more than enough room for all of our welds for full penetration. I'll be able to have an order that they go back together where we can keep fully welding them, because we're going to want that halo welded in and the down bar in the back welded in before we put in our diagonal bar that then covers up those welded areas, so that we have weld inside on all the way around each individual tube before we put a tube over the top and then weld that all the way around it also. There, after a little bit of back and forth, we've got a node that fits really nice all the way around. Again, it's not absolutely perfect, but by the time I get done grinding out material in order to make sure that we've got a good weld all the way around, it'll be plenty good enough. So it's lined up with the main hoop. It's nice in plane with that. So that was the important part, being as it's the diagonal bar for the main hoop. And then how the other tubes kind of fit in is just getting them back to their original positions and making sure that everything can set and rest together like that. And we also have to worry about that after it is welded on those other tubes, if we do have weld that's stacked up a little higher, we're going to have to go back and clearance whatever tube we haven't welded already yet a little bit more to clear that weld. Alright, I think this is a good stopping point for this video. Typically, I'd put diagonal also in the rear down bar area. However, looking at it, we might have some clearance issues with the 3-link rear suspension upper arm. Just the way things are planning out, especially because I'm shooting for doing a decoupled 3-link, which means we're gonna have a lot of suspension business going on in this general area, and it might get up into that plane. These bars could always get shot farther back on the frame rail, but I really want them tied into the suspension points, just because That way, any energy going through the suspension is all getting directly put into the chassis and not into somewhere between a solid point where it might be causing any flexing. Not that we need to be super worried about that anyway. It's just, you know, the more rigid we can build it at all the chassis points, the more rigid everything's going to be in between. Definitely going to need to jump into doing the front suspension area going forward. However, I don't want to commit to anything up there until I get the engine and transmission mocked back up. We need to make sure that our dash bar tube is not going to cause any issues with the trans tunnel, the firewall, or anything on the engine actually. There might be some concern with proximity to like a distributor. I am planning on going coil near plug with that engine. However, I still need something back there to be a cam sync. Unless I figure out something to do off the front of the engine, which is very much a possibility because I won't be running a water pump on the front anyway, because we're going to run the dry sump off of the cam and probably do an electric water pump. There's options with what we got going on. It's just a matter of I want to make sure that everything clears. Once I'm committed to a dash bar position that I like, then we can build the bars going forward. So there's going to be some work off camera in the meantime to get all that prepped and ready. Everything back here is pretty good. I mean, like our hard welds, you know, are still going to be the roof section and what we're going to do about moving the body. I think it'd be great to get a few more bars put in, and especially like the stuff in the front, because the more stuff I have that kind of interacts with the body as is, the more likely I am to have everything sit back into position, especially if I do decide to just lift the whole body off and it gets all kind of wonky. It should be able to just like rehome itself going back on because of how much stuff we got touching the body all over.